Myself, Virendra Kumar, and we are going to discuss about the helium neon laser. It is the first gas laser to be operated successfully. It was developed at Bell Telephone Laboratories in 1962. As we know that in a solid state lasers, pumping is done using a flash lamp or a continuous high power lamp. Such technique is efficient if the lasing system has broad absorption bands. But in the gas lasers, the atoms are characterized by sharp energy levels as compared to those in solid state lasers. Hence, we generally use an electrical discharge technique to pump atoms from ground state to the excited energy states. Here in this picture, there is a helium neon laser placed in the University of Chemnitz in Germany. So, helium neon laser is a continuous laser and its color falls in the visible range of red light. Now, let us discuss about the construction of the helium neon laser. The helium neon laser consists of a long and narrow discharge tube having diameter about 2 mm to 8 mm and length about 10 to 100 centimeter. This tube is filled with a mixture of helium neon noble gases with a typical pressure of 1 torr. 1 torr is equal to 1 millimeter of Hg and zero point 0.1 torr, that is zero point 0.1 millimeter of mercury, and the helium neon gases are in the ratio of 10 is to 1. The discharge tube here, this is a discharge tube in which this mixture of gases are kept, and this discharge tube is made up of Pyrex glass. So, friends, I will ask many important questions after this lecture, and you have to give the answers of all those questions in the comment box. So, please watch the video lecture very carefully. This glass tube, discharge tube, is made up of Pyrex glass. There are plain glass at both ends of this tube, that is this two plain glass says. These plain glass are made up of borosilicate. So this plain glass is nothing but is a Brewster's window, and these Brewster's windows are kept at the Brewster's angle. So I will discuss about this Brewster's window, Brewster's angle, and Brewster's law in detail. Here, mirror M1 is the 100% reflecting mirror. That means there is no transmission of any light outside of this. tube at this end, and this mirror M2 is partially reflected. That means there is a chance of transmission. Let there is a chance of 10% transmission of the light. These plain glasses kept at the Brewster's angle or the Brewster's window. So why Brewster's window is used at the end of discharge tube? That is a very important question. I will discuss just right now. Now, the laser resonator consists of the mirror M1 and M2. Why these two mirrors are used? These are used to increase the intensity of the laser, and because of the multiple reflection of the laser light from these mirrors, the intensity increases. Here, discharge tube is connected with the electric cathode and anode terminals to create a electric discharge in this tube. Now we'll discuss the working principle of helium neon laser. Before that, let us observe this millisgraute helium neon laser cross section. Friends, you can observe from this cross-sectional diagram how the millisgraute helium neon laser is constructed. Here, built-in shutter is given to prevent inadvertent exposure. So this shutter is given for the prevention of inadvertent exposure of the laser light. Second, this this is the cathode connection through housing for safety and simplicity. And this is the precision positive collimating lens that supports output mirror coating. Similarly, this precision borosilicate bore optimum mode filling better angular stability. So this small tube is given for the better angular stability. Now you can see that this precision mirror adjustment for the fine but stable alignment. Here, so in the modern laser system, helium neon gas laser system, the various typical arrangements are given to better utilization of the helium neon laser. Now, optional Brewster window for high polarization purity. So, Brewster window is given here one side only in this Miller's Griat helium neon laser, but in other helium neon laser, both sides you can have the Brewster window. Okay, so this is just a typical Miller's Griat helium neon laser cross section. Now we'll discuss the Brewster's law and Brewster window. Friends, when light incidents on interface between two media with different refractive indices, some part of it is reflected and some part is refracted. Here in this picture, this is the incident ray falling at this interface. So there are two media, medium 1 and medium 2. So this incident ray is unpolarized. That is, it has Both. It has two components of the light, that is one in the plane of the incident and other that is the perpendicular to the plane of the incidence. But if the light happens to incident at this interface at angle theta b, that is the Brewster's angle, it gets reflected with the vectors, that is the vibrations perpendicular to the plane of incidence, and rest is refracted. Here you can see the refracted ray has the components of vibrations along the plane of the incidence. This also has few vector that is perpendicular to the plane of incidence. That means this refracted ray is slightly polarized, but this reflected ray is completely polarized. So the essence of this Brewster's law is that if the unpolarized light incident at the particular angle, that is the Brewster's angle, then it's get reflected with the polarized vibrations in a particular direction, and other part is refracted that may have slightly polarized light. So the fraction that is reflected is described by the Fresnel equations, and it depends on the incident angle and incoming light's polarization, right? The Fresnel's equation predict that light with p polarization will not be reflected if the angle of incidence is equal to the Brewster's angle, right? So p polarization means what? The light with p polarization will not be reflected. Here you can see that the reflected ray is having only the vibrations of the electric and magnetic field perpendicular to the plane of incidence. That means the p polarization is the light in which the vibrations of the vector are along the plane of incidence. That means this light with this p polarization will not be reflected, but it will be transmitted, that will be refracted at this interface. Okay, so the Brewster's angle is given by this equation, theta b is equal to tan inverse mu2 by mu1, where mu1 and mu2 are the refractive indices of the media. So here mu1 is the refractive index of the first medium in which the light is incident, and mu2 is the refractive index of the second medium. Right? This equation is known as Brewster's law. So we use in this helium neon laser this principle for getting the polarized light in terms of the laser beam. That's why we use Brewster window, and we place this Brewster window, that is nothing but the plain glass of the borosilicate, right? So this glass is kept at the angle of Brewster angle, and for the given refractive index of 1.5, this Brewster angle is about 57 degree. So if incident polarized light is falling at this Brewster window that is kept at the Brewster angle, the there is no reflection, because this is the nothing but the p polarized light, right? So there is no reflection. All the light is getting transmitted, right? That is the essence of the Brewster window. Now, working principle of the helium neon gas laser. Friends, in the helium neon gas laser, the actual lasing atoms are neon. Then why we use the helium atoms mixed with the neon? This is because neon atoms are heavier and helium atoms are lighter. For pumping neon atoms, they require larger initial energy to get excited, while helium atoms are excited by absorption of small energy input. Hence, helium atom is used for a selective pumping of the upper laser level of neon. When an electrical discharge is passed through the gas mixture of helium neon, the electrons are accelerated through the tube, this tube, and they collide with the helium and neon atoms. So after electron getting accelerated, they do collision with the helium and neon atoms in this discharge tube, and they excite helium atoms to higher energy levels, right? So what we happen, the helium atoms tend to accumulate at levels F2 and F3 due to their long life times of 10 to the power minus 4 seconds. So these two levels are known as the meta-stable states. That means F2 have the 10 to the power minus 4 and F3 is having the 10 to the power minus 6 second lifetime. Right? Here F2 and F3 levels are the metastables and are the excited states of the helium atoms. We have here written the 2 3s1 and 2 1s0. These are nothing but the ls notation for the terms. These energy levels, as I told you, are the metastable states. Now, since the levels E4 and E6 of neon atoms have almost the same energy as F2 and F3 of the helium atoms, the excited helium atoms at these metastable states collide with the neon atoms at the ground energy levels. Because of this inelastic helium-neon collision, helium atoms transfer some of its excitation energy to neon atoms, and hence neon atoms excited to higher energy levels of E4 and E6. Further, since the pressure of helium is 10 times that of neon, the levels E4 and E6 of neon are selectively populated as compared to other levels of neons. Therefore, here pressure also plays an important role. As I discussed that the pressure of the helium is about 1 torr and pressure of neon is zero point 0.1 torr. This is the reason pressure is being kept 10 times to the pressure of neon. Now, the transition of neon between E6 to E3, the transition E6 to E3 of neon from this E6 level to E3, this level produces the very popular 6328 angstrom line of the helium neon laser. This is the red color falling in the visible range of the light, and this transition from E to E6 to E3 is the lasing action of the helium neon laser. Neon atoms thereafter de-excite through spontaneous emission from E3 to E2, and at E3 level it remains only for 10 to the power minus 8 second. Therefore, the level transition from E3 to E2 is spontaneous transition, not a laser emission transition, and here the lifetime is 10 to the power minus 8 second. Okay, now since the lifetime of level E3 is shorter than the lifetime of level E6, so here I have mentioned that the lifetime of the level E6 is 10 to the power minus 7 second, and here it is 10 to the power minus 8 seconds. So level of this E3 lifetime is very shorter than the level of E6. One can achieve steady state population inversion between E6 and E3. So this transition is achievable because of this lifetime difference of the two levels, that is almost 10 times difference, and it is easily possible for attaining the population inversion. Level E2 is metastable. This level E2 is metastable level and thus tends to collect neon atoms. Here, after E3 to E2, neon atoms are stayed here for the longer time. The neon atoms from this level relax back to the ground level mainly through collision with the walls of the tube. So this transition is the diffusion non-radiation transition, and from this level E2 to ground level E1, neon atoms generally come with the diffusion and collision through the walls of the tube. Now, since level E2 is metastable state and its lifetime is 10 to the power minus 8 second, it is possible for the atoms in this level to absorb the spontaneously emitted radiation in the transition E3 to E2. So E3 to E2 there is a transition, and this because of this transition there is a emission of the radiation, and this since this is a metastable state, therefore in this level atoms can absorb this radiation and then to be re-excited to the E3 level, and this will have the effect of reducing the population inversion. Because of this reason, the gain in this laser transition is found to increase with the decreasing tube diameter. The other two important transitions are E4 to E3, in which 1.15 micrometer IR radiation is emitted, and E6 to E5, in which 3.39 micrometer IR radiation is emitted. So E4 to E3, this E4 to E3, this transition, and E6 to E5, this transition. These transitions are higher wavelength transitions, and they are falling in the IR region, infrared region. It is also important to note that both these 3.39 micrometer and 1.15 micrometer transitions may create problems. Therefore, we use the quartz glass discharge tube which absorbs these type of radiations, and then thereby these radiations are eliminated from the main targeted laser light 6328 angstrom. Also, you should focus here that this transition E6 to E5 and E6 to E3 are sharing the same upper energy level E6. Now, since the 3.39 micrometer transition corresponds to a much lower frequency than this 6328 angstrom line, the Doppler broadening is much smaller at this value 3.39 micrometer. And also, since gain depends inversely on the square of frequency, that is, gain is inversely proportional to the square of the frequency. Therefore, gain at 3.39 micrometer is much higher than at 6328 angstrom radiation. Thus, due to the very large gain, you can see here that since gain is inversely proportional to the square of the frequency, therefore, due to the very large gain, oscillations will normally tend to occur at 3.39 micrometer rather than 6328 angstrom. Once the laser starts to oscillate at 3.39 micrometer, further buildup of population in E6 level is not possible. So the laser can be made to oscillate at this wavelength by either using optical elements in path to absorb the 3.39 micrometer wavelength, or by increasing the line width through the Zeeman effect by applying the inhomogeneous magnetic field across the tube. Generally, what we do that we use Pyrex glass or quartz tube for the helium neon laser so that this Pyrex glass or the quartz tube absorb such kind of unwanted radiation frequency. Right? Now, if the resonator mirrors are placed outside the discharge tube, here in this figure, suppose these resonator mirrors are placed outside of this glass tube, they are placed outside of this glass tube, right? Then the reflection from the ends of the discharge tube is possible. Okay, so deflection may be possible from the ends of the glass tube. So to avoid such kind of reflection from the ends of the discharge tube, we place the Brewster window at the end of the discharge tube. Okay, and there is also a benefit which I have already discussed for the using the Brewster window. Okay, now let us discuss about the characteristics of the helium neon gas laser. So there are following characteristics of the helium neon laser. Let us discuss one by one. So first of all, this helium neon laser is a gas laser and it is four level laser. So you can ask me how it is a four level laser. You can see from the energy level diagram that first level, when we pump the ground energy state helium atom to the higher energy state F3, becomes the first level. Now, after transferring its energy to the neon atoms, the neon atoms radiate and comes to the level E3 from E6 to E3. So this becomes second energy level. And from E3 to E2, this becomes third energy level. And finally, from E2 level, it comes to the ground and state. So that becomes the fourth energy level. So that's why helium neon laser is a four level laser. In this, active medium is helium with the neon noble gases. And these two gases are noble gases. They don't interact with each other. That is one of the benefits of taking the helium and neon together in the ratio of 10 is to 1 because they don't react with each other. Okay. Fourth, helium neon laser is a high efficiency laser. Fifth, the helium neon laser is a continuous laser rather than pulse laser as in the case of the solid state laser. Electric discharge is used in case of the helium neon laser for pumping to achieve the population inversion. No external cooling system is required in case of the helium neon laser. And it is a very low power laser, about 50 milliwatts. We can achieve from the helium neon laser. So only that much power of laser can be achieved with the help of the helium neon laser. So it is a very low power laser system. The helium neon gas laser is more directional, more monochromatic in nature and coherent in comparison to the solid state lasers. Okay friends, now let us discuss the applications of the helium neon lasers in different sectors. So helium neon laser is a very useful for many applications such as we use helium neon laser in holography for producing 3D images of the objects. Because of its low power energy, it has been extensively used for barcode reading, to retrieve the coded information. You might have noticed that barcode reader is used in the mall and other shopping complexes. That is nothing but the helium neon laser. It is also used for communication purposes. It is used in science and engineering experiments related to optics for the demonstration. Okay, so friends, in this video lecture, I have discussed about the helium neon gas laser, its introduction, construction, working principles, energy level diagram, Brewster's window, Brewster's law, Brewster's angle, and P-polarization and characteristics of the helium neon laser and helium neon laser applications in different sectors. I hope that you have enjoyed this video lecture. Now, this is the time of question. You must have, I guess, that you listen the lecture and watch this video lecture carefully. Now, I will ask few questions and you have to give the answers of those questions in comment box. The question number one, tell me the place where for the first time helium neon laser was successfully developed. Question number two, why we use quartz or pyrex glass for discharge tube? And question number three, what is the use of Brewster's window in the helium neon laser? Question number four, tell me the transition levels between which the lesser light of 6328 angstrom is emitted. And the last question, which is very important, question number 5. Give the relationship for gain and frequency. So these are the questions which you have to give the answers in the comment box. If you provide the correct answers, I will assume that you have understood the entire video lecture very well. So thank you friends for watching the video lecture, and if you have not subscribed the Sai Academy channel, please subscribe right now and press the bell icon for getting the notification of the upcoming video lectures. Thank you. Stay tuned. Bye bye.